What if the most important discovery in human history appeared for just 1/30th of a second before the screen went black? On June 18, 2025, a NASA live feed tracking our third interstellar visitor, 3I Atlas, cut out at the exact moment a bizarre, unnatural-looking object flashed into view. The data is real, the blackout is confirmed, and the final frame is undeniable. Was it a glitch, a cover-up, or our first glimpse of alien technology? Let's delve into it. The initial discovery. How do you spot a messenger from another star system? You build a robotic sentinel to watch the entire sky. The Asteroid Terrestrial Impact Last Alert System, or ATLAS, is a network of telescopes designed to do just that. On July 1, 2025, its automated systems flagged an object on a trajectory that immediately set it apart. Its path was hyperbolic, a clear sign it wasn't gravitationally bound to our sun. Much like Robert Warwick's 2017 discovery of Oumuamua, this was identified not by a single astronomer staring through an eyepiece, but by sophisticated software analyzing vast amounts of data. The object's extreme velocity and angle of entry confirmed it was a one-way visitor from the interstellar void. The Minor Planet Center, under the direction of Matthew Holman, quickly issued a circular designating it 3Y Atlas, confirming it as only the third such object ever detected. The global response was immediate and intense. With this early detection far earlier than Oumuamua was spotted, telescopes worldwide scrambled to observe the cosmic wanderer. This was a rare chance to study a piece of another solar system in unprecedented detail, a pristine time capsule from an unknown corner of the galaxy. The anomalous frame. What does a cosmic anomaly look like up close? At exactly 03:17 and 12 seconds UTC on that June night, just fractions of a second before the feed went dark, we got a shocking clue. The last recorded frame from the NASA feed shows what at first appears to be a standard cometary image, a dim nucleus, a hazy coma, and a faint tail. But in the lower left quadrant, something is fundamentally wrong. A razor-straight glint of light slices across the image. It's not a curve or an arc, it's a geometric edge, sharp and utterly at odds with the soft, natural contours of a comet. Independent astronomers inspired by the work of Karen Meach, who meticulously analyzed Oumuamua's strange light curve, immediately ran edge detection algorithms on the frame. The software flagged an almost perfectly straight line segment, measuring about 37 pixels from end to end. It reflected sunlight at a clean, sharp angle, unlike the diffused, scattered streaks expected from irregular comet dust. The light bounced as if from a polished, machined surface, not fractured ice or rock. It was a single, fleeting glimpse of something that, according to our understanding of cometary physics, simply shouldn't be there. Data verification. How do you prove a ghost in the machine is real? You check its digital fingerprints. In the world of astronomical data, this means cryptographic hashes and independent confirmation. Within minutes of the blackout on June 18, 2025, independent archivists in Australia, Germany, and the United States uploaded their own continuous packet captures of the NASA feed. Each file, stamped with the same 03:17 and 12 seconds UTC timestamp, came with a unique SHA-256 hash. When compared, every copy was identical, bit for bit. The hash for the Australian archive ending in 4F8D matched the German mirror and the original NASA relay. There was zero evidence of tampering. This is the new reality of citizen science, a decentralized backbone for data integrity that echoes the principles of transparency championed by figures like the late Carl Sagan. These archivists logged their actions in public ledgers, creating an airtight chain of custody. The anomaly appears in every single version of the feed, from the raw data streams to the compressed video. The data is clean, the archive is verified, and the mystery, preserved immutably, remains untouched by claims of digital alteration. Technical explanations. So why did the feed go black at that exact moment? The official line honestly points to mundane network logistics. NASA's live feeds are, well, a complex ballet of signals bounced between the tracking and data relay satellite system and the three main ground stations of the Deep Space Network in California, Spain, and Australia. According to engineers like Leslie Deutsch, a veteran of JPL who helped design parts of the DSN, dropouts are routine. When a satellite moves out of position or a signal is handed off between continents, you can get a brief interruption, often seen as a 2-second gray screen. These are called handover blanks, and they are logged with specific reason codes. They are usually just a consequence of orbital mechanics, a predictable part of space communication. This explanation, accounts for the blackout itself as a technical hiccup, but the timing is what troubles investigators. Was it just a 1 in a million coincidence that this routine glitch occurred at the precise second a geometric anomaly, unprecedented in nature, appeared on screen? The official logs confirm the handover but can't explain the timing. Digital forensics. Can a simple glitch really look that perfect? Digital forensics teams, applying techniques similar to those used by experts like Hani Farid to analyze video authenticity, put the frame under a microscope. They found some compelling evidence for the skeptics. When they zoomed in, they noticed the sharp edge ran perfectly parallel to the borders of several 8x8 pixel macro blocks. That's a classic fingerprint of the MPEG video compression used for the feeds. NASA's algorithms slice each frame into a grid and can sometimes exaggerate faint lines. Then there's the issue of cosmic rays. Space is filled with high-energy particles that can slam into a camera's sensor, leaving a bright white streak for a single frame. This is a common artifact. It is entirely possible that a random cosmic ray hit was amplified by the video codec, creating the illusion of a solid edge. A double hit, a fleeting natural event made to look artificial by software. It's a highly plausible theory, one that relies on known phenomena. But does it fully explain the crispness and consistent brightness along the entire 37-pixel edge? That remains the heart of the debate. 3i Atlas background. What do we actually know about this interstellar traveler? Even without the anomalous glint, 3i Atlas is a cosmic outlier. Spectroscopic analysis from the James Webb Space Telescope's MIRI instrument, a device overseen by scientists like Gillian Wright, revealed it's unusually rich in carbon dioxide. The ratio of CO2 to water is about 8:1, far higher than comets from our own Oort cloud. This means its activity, the outgassing that creates its coma, is driven by frozen carbon dioxide turning to gas, not water ice. The coma itself is vast, stretching for hundreds of thousands of kilometers, with a dust cloud so dense it completely hides the nucleus. Based on its brightness, astronomers estimate the solid core is likely less than a kilometer across, comparable to 2 Borisov. Its early detection on July 1, 2025 by the Atlas survey gave scientists a crucial head start. It allowed them to watch this messenger from another star system come alive as it approached our sun, a process that has already yielded surprising new science about the chemistry of other planetary systems. Scientific scrutiny. So, how does a wild claim actually become an accepted fact in science? Well, it has to survive a pretty brutal gauntlet of scrutiny. Right now, the evidence for anything artificial on 3i Atlas sits, honestly, on the very first rung of the ladder of evidence. We're talking about a single anomaly in a single frame. To climb any higher, it really needs independent verification. On one side of the debate, you have cautious figures like astrophysicist Katie Mack, who would argue that we have to exhaust every possible natural and instrumental explanation before even considering an artificial one. On the other hand, there are thinkers like Harvard's Avi Loeb, who says that the discovery of Oumuamua already opened the door to considering technological origins for interstellar anomalies. For 3i Atlas, astronomers would need to see that same geometric edge with the Hubble, or maybe detect a strange spectral signature with ground-based scopes that matches a known alloy. Without multi-instrument confirmation, the scientific community will remain deeply skeptical, and honestly, rightly so. The edge remains a tantalizing but unproven candidate. 3 theories. So, where does this leave us? The debate is really fractured into 3 distinct paths. The first is a natural explanation based on cometary physics. As 3i Atlas heats up, jets of carbon dioxide erupt from its surface, which, honestly, can be strong enough to change its spin and break off shards of ice. The glint we saw could just be sunlight hitting the fresh, flat face of a newly fractured piece. The second path, which is actually favored by many, points to a technological illusion, a chance collision of a cosmic ray and a video compression artifact. But the third idea, while definitely the most speculative, stubbornly persists. What if the glint is from a machined surface? Proponents of this view, echoing the logic Avi Loeb applied to Oumuamua, suggest we could be looking at a probe or maybe even a piece of a larger craft. While Loeb's theories about Oumuamua were met with skepticism, Astronomers like Darrell Seligman have since proposed that natural nitrogen icebergs could explain its behavior. But for 3I Atlas, no such elegant natural theory has yet emerged to explain the perfectly straight edge, which, honestly, keeps the artificial hypothesis uncomfortably on the table. Broader implications. An event like this, well, it ripples far beyond astronomy forums. When a NASA feed cuts out at such a critical moment, it really ignites a firestorm. Suddenly lawmakers are asking about data transparency protocols, and research teams are pushing for more open archives. It forces us to confront who actually controls the flow of information. It also galvanizes projects like the Galileo project, co-founded by Avi Loeb, which is dedicated to actively searching for extraterrestrial technological signatures. Figures like Seth Shostak of the SETI Institute have long argued that any potential discovery would have profound societal implications. The 3I Atlas incident is, honestly, a perfect test case. It has raised the stakes, transforming a niche scientific question into a global conversation about our readiness for a discovery that could, change everything. The next time a feed from deep space drops, more eyes will be watching and more citizen archivists will be recording, ensuring the data remains in the public square. The search continues. The tantalizing mystery of 3I Atlas has already had a massive impact. It's injected a new sense of urgency into the search for interstellar objects. The Vera C. Rubin Observatory, under the leadership of director Zeljko Ivezic, is poised to discover dozens of these visitors every year as it begins its legacy survey of space and time in 2025. This will really transform the field from one of single, bizarre case studies into a robust statistical science. We will finally be able to determine if objects like 3I Atlas, with its strange composition and that anomalous glint, are common or exceedingly rare. Will we find more Oumuamuas and Atlases, or will they all look like the conventional comet 2I Borisov? The search is no longer just about finding rocks from other stars, it's about being prepared to find something we never expected. The next visitor is coming, and honestly it might just bring the answer with it, forcing us to finally confront the evidence, whatever it may be. The case of 3I Atlas remains unsolved. We have a single, provocative frame of data, verified and preserved, showing something that really defies easy explanation. We have a perfectly timed blackout that fuels speculation. And we have a set of competing theories, from a natural fracture to a cosmic glitch, to an artificial object. For now, it sits in digital limbo, a testament to how much we still have to learn about the universe. The only thing we know for sure is that the next visitor from the interstellar darkness is on its way, and this time, humanity will be watching more closely than ever before. Don't forget to like, subscribe, and hit the bell icon for more deep dives into the mysteries of our cosmos. Thanks for watching Sci and Why. Voyager 1 is a breathtaking testament to human ingenuity and curiosity. Launched in 1977, this remarkably small spacecraft has traversed the vast reaches of the solar system and beyond, venturing where no human-made object has gone before, into interstellar space. As it now drifts deeper into the unknown, Voyager 1 continues to send back invaluable data about the cosmic environment beyond our sun's influence. Recent observations hint at phenomena that both challenge and confirm fundamental aspects of astrophysics, revealing mysteries that hold profound implications for our understanding of the universe. The birth of a star sailor. In the early 1970s, the Voyager program was conceived as a bold mission to explore the outer planets with unprecedented detail. The Voyager 1 spacecraft, roughly the size of a small car, was designed for durability and autonomy, equipped with a golden record, an interstellar message recording the diverse sounds and images of Earth. Directed by Dr. Ed Stone at NASA's Jet Propulsion Laboratory, the mission successfully navigated the grand tour of Jupiter, Saturn, Uranus and Neptune, leveraging gravity assist to extend its reach. Despite limitations in technology at the time, Voyager 1 continues to operate nearly 45 years after launch, a marvel of engineering resilience still beaming secrets from the edge of the solar system. The spacecraft's design prioritized robust systems capable of operating autonomously over decades, with minimal intervention due to the communication delay of over 18 hours at the edge of the solar system. The mission also carried groundbreaking scientific instruments designed to analyze planetary atmospheres, magnetic fields, and charged particles. Voyager 1's findings redefined our understanding of planetary formation and magnetic dynamo processes, revealing complex interactions within gas giants that challenged established physics. Most remarkably, the probe's longevity has surpassed initial expectations, continuing to provide valuable data well into the 21st century. The Grand Tour. Voyager 1's Grand Tour was a triumph of celestial navigation and scientific ambition. Utilizing precisely timed flybys, Voyager 1 collected invaluable data about the gas giants, revealing dynamic atmospheres, complex ring systems, and magnetic phenomena previously undreamt. Under the stewardship of Flight Director Suzanne Dodd and project scientists at JPL, the spacecraft gained speed from gravitational slingshots at Jupiter and Saturn, ultimately escaping the solar system's grasp. Visuals of Jupiter's storms and Saturn's rings reshaped planetary science, inspiring a generation and setting the stage for interstellar exploration. Each encounter enriched our knowledge, paving the way for humanity's journey into the galactic abyss. The success of the Grand Tour opened doors for extended missions including Voyager 2 and Pioneer 10 and 11, setting a new standard for deep space exploration. Data transmitted reshaped our comprehension of planetary weather, magnetic environments, and ring systems, influencing models used in current astronomical research. Voyager 1's trajectory post-Saturn escape set the stage for humanity's first venture into interstellar space, marking a milestone achieved by no craft before. The meticulous planning and execution underpinning the mission exemplify the extraordinary human drive to explore beyond current horizons. The Golden Record. Embedded within Voyager 1 is the famous Golden Record, a time capsule crafted to communicate humanity's story to any extraterrestrial intelligence that might encounter it. Curated by a distinguished committee led by astronomer Carl Sagan, this 12-inch gold-plated copper disc includes greetings in 55 languages, music from diverse cultures around the world, and 116 encoded images depicting life on Earth. The record serves as a symbol of hope, friendship, and cosmic connection, acoustically traversing the vast gulf between stars as Voyager sails silently through the void. Its cover includes a pulsar map and scientific diagrams designed to communicate Earth's location in the galaxy to any intelligent beings who might find it. The selection process involved extensive deliberation about what aspects of human culture and knowledge would be most representative and comprehensible to alien minds. Beyond its scientific mission, the Golden Record transforms Voyager 1 into a cultural ambassador, carrying the essence of human civilization into the cosmos. This remarkable artifact represents humanity's first serious attempt at interstellar communication, embodying our deepest hopes for contact with other intelligent life forms in the universe. The record's contents reflect both our diversity and our common humanity, serving as a testament to Earth's rich cultural heritage. Years in the void. After completing its primary mission to the gas giants, Voyager 1 embarked on its extended journey through the outer solar system and beyond. For over 4 decades, this resilient spacecraft has continued to function in the harsh environment of deep space, enduring extreme cold, radiation bombardment, and the complete isolation of the cosmic void. Its instruments persistently measure solar wind particles, magnetic field strength, and cosmic ray intensity, delivering unprecedented insights into the heliosphere's structure and boundary. Despite operating far beyond its original design parameters, Voyager's radioisotope thermoelectric generators continue to provide sufficient power to maintain communication with Earth. The spacecraft's remarkable longevity has allowed scientists to study long-term variations in the solar system's outer regions, and observe the gradual transition from solar-dominated to galactic-dominated space. Each data transmission, traveling over 14.5 billion miles to reach Earth, represents a triumph of human engineering and perseverance. Mission controllers have had to make increasingly difficult decisions about which instruments to keep active as power levels slowly decline. The probe's survival in this hostile environment has provided invaluable lessons for designing future deep space missions intended to explore even more distant destinations. Crossing the boundary. On August 25, 2012, Voyager 1 achieved a historic milestone by crossing the heliopause and entering interstellar space, becoming the first human-made object to leave the solar system. This momentous transition was marked by dramatic changes in the particle environment, a sharp increase in cosmic ray intensity, and a corresponding decrease in solar wind particles. Mission scientists led by Dr. Stamatios Kremigis carefully analyzed the data to confirm this unprecedented boundary crossing, which had been anticipated for years. The heliopause represents the edge of the heliosphere, the vast bubble of charged particles and magnetic fields created by our sun's solar wind. Beyond this boundary lies the interstellar medium, a realm filled with materials from other stars and the remnants of ancient stellar explosions. Voyager's instruments detected the sudden change in magnetic field orientation and particle composition that definitively proved it had entered this new domain. The crossing provided the first direct measurements of interstellar space, confirming theoretical predictions while also revealing unexpected complexities in the boundary region. This achievement marked the beginning of a new era in space exploration, as humanity finally had a probe operating in the galactic environment. The data collected during and after the crossing continues to reshape our understanding of how our solar system interacts with the surrounding galaxy. Signals from nowhere. In recent years, Voyager 1 has transmitted increasingly puzzling data that challenges our understanding of interstellar space. The spacecraft has detected mysterious plasma wave oscillations and unexpected magnetic field fluctuations that appear to have no obvious source or explanation. Dr. Larry Esposito and his research team have identified these anomalous signals as potential evidence of previously unknown interstellar phenomena or structural irregularities in the galactic medium. The signals from nowhere suggest that the space between stars is far more dynamic and complex than previously imagined, with rich physical processes occurring in regions once thought to be relatively empty. These mysterious transmissions have sparked intense scientific debate, with some researchers proposing they indicate interactions with dense interstellar clouds or magnetic field reconnection events. Others suggest the signals might represent encounters with the shock waves of distant stellar explosions that have propagated across the galaxy for millions of years. The data patterns don't match any known astrophysical models, forcing scientists to reconsider fundamental assumptions about the nature of interstellar space. Voyager's continuing journey deeper into this mysterious realm promises to reveal even more surprising discoveries about the hidden dynamics of our galactic neighborhood. The temperature mystery. One of the most perplexing anomalies discovered by Voyager 1 involves unexplained temperature fluctuations that defy conventional understanding of deep space thermal dynamics. Despite moving steadily away from the sun and into the cold depths of interstellar space, the spacecraft's sensors have recorded puzzling warming events that contradict expected cooling trends. Dr. John Napick leads the engineering team investigating these thermal anomalies, which could result from several possible mechanisms, including interactions with interstellar dust particles or energetic cosmic ray bombardment. The temperature variations might also indicate encounters with warmer regions of the interstellar medium or internal spacecraft issues affecting sensor calibration. These thermal mysteries have significant implications for mission longevity, as temperature extremes can impact the performance and lifespan of critical onboard systems. Understanding these fluctuations is crucial for predicting how long Voyager's instruments will continue functioning and for designing thermal protection systems for future interstellar missions. The spacecraft's ability to endure such extreme and variable thermal conditions far exceeds original engineering predictions, providing valuable insights into spacecraft survivability in the harsh interstellar environment. Resolving the temperature mystery remains one of the mission's most important ongoing challenges, as it affects both scientific interpretation and operational planning. Changing course. Maintaining Voyager 1's precise trajectory and communication alignment has required increasingly sophisticated navigation techniques as the spacecraft ventures deeper into interstellar space. Under the expert supervision of Flight Director Suzanne Dodd, mission controllers have executed subtle but critical thruster maneuvers to counteract natural orbital drift and maintain optimal antenna pointing toward Earth. These delicate course corrections ensure that Voyager's weak radio signals, transmitted with just 20 watts of power, continue to reach NASA's Deep Space Network receivers despite the enormous distance. The navigation team faces unprecedented challenges in predicting and correcting the spacecraft's path, as traditional gravitational models become less applicable in the interstellar environment. Recent trajectory adjustments have revealed unexpected external forces acting on the spacecraft, possibly related to pressure from interstellar gases or magnetic field interactions. The precision required for these maneuvers is extraordinary, considering that Voyager is now traveling at over 38,000 miles per hour, relative to the Sun, and any navigation error compounds over vast distances. These course changes also provide valuable scientific data about the forces and conditions Voyager encounters in its interstellar journey. The ongoing navigation challenges demonstrate the remarkable dedication and expertise of the mission operations team in maintaining contact with humanity's most distant emissary. Ghost in the machine. Voyager 1's aging systems have begun exhibiting strange anomalies that mission engineers have dubbed the ghost in the machine. Unexplained glitches and data irregularities that seem to have no identifiable cause. The most prominent of these anomalies involves the spacecraft's attitude articulation and control system, which began sending garbled telemetry data that didn't match the probe's actual orientation and movement. Dr. Emma Woodfield leads the team investigating these mysterious system behaviors, which could result from cosmic ray damage, software degradation, or unexpected interactions between aging components. The anomalies became so severe that mission controllers temporarily lost the ability to determine Voyager's exact orientation in space, creating significant challenges for maintaining communication with Earth. After months of detective work, engineers managed to switch to a backup system and restore normal operations, but the incident highlighted the precarious nature of operating 46-year-old technology in the harsh interstellar environment. These ghost phenomena provide valuable insights into how spacecraft systems degrade over extreme timescales and help engineers design more robust systems for future long-duration missions. The successful resolution of these problems demonstrates the ingenuity and persistence of NASA's engineering teams in troubleshooting unprecedented technical challenges across interstellar distances. Patterns within patterns. Recent analysis of Voyager 1's scientific data has revealed intricate and unexpected patterns within the interstellar medium that suggest a far more complex and structured galactic environment than previously imagined. Dr. Harold Kruger directs ongoing research that has identified filamentary structures, spiral magnetic field configurations, and turbulent plasma waves swirling around the spacecraft's location. These patterns within patterns indicate sophisticated magnetic and energetic phenomena operating on multiple scales throughout interstellar space, from local turbulence to vast galactic structures. The observations suggest that the space between stars is not empty void but rather a dynamic, ever-changing medium filled with invisible currents and forces that shape the galactic environment. Voyager's measurements have detected evidence of shock waves from ancient stellar explosions, magnetic field boundaries between different regions of space, and complex interactions between interstellar gas and cosmic ray particles. These discoveries are revolutionizing our understanding of galactic physics and the processes that govern matter and energy flow throughout the Milky Way. The patterns Voyager observes may represent the fundamental architecture of our galaxy, revealing how stars, gas, and magnetic fields interact to create the large-scale structure we see in the cosmos. Each new data transmission adds another piece to this cosmic puzzle, gradually unveiling the hidden dynamics that govern our galactic home. Voyager 1's extraordinary journey continues to astonish scientists and space enthusiasts worldwide as it ventures deeper into the unknown reaches of interstellar space. The mysterious phenomena and unexpected discoveries it encounters challenge our fundamental understanding of the cosmos while revealing the incredible complexity of the galactic environment. What aspect of Voyager's journey fascinates you most? Share your thoughts in the comments below and subscribe to Sci and Y for more incredible stories of cosmic exploration and discovery. Until next time, keep looking up and wondering about the vast universe around us. What if NASA found conclusive proof of alien technology, but decided to hide it from the world? 3 weeks ago, a hacker group calling itself Event Horizon claims to have done the impossible, pulling 24 gigabytes of classified mission data from NASA's secure servers. The target? A mission to intercept 3I Atlas, the third interstellar visitor ever detected. The files hint at a cover-up of cosmic proportions. So what did they find that was so disturbing? Let's explore this together. Event Horizon's cyber attack. So how does a clandestine group get its hands on NASA's crown jewels? According to the leaked security logs, this wasn't a brute force attack, it was surgical. In the early hours of September 2, 2025, Event Horizon executed a coordinated cyber attack that bypassed multiple layers of agency firewalls. They exploited a zero-day vulnerability in an outdated Fortran-based mission planning module, a tiny crack in an otherwise formidable digital fortress. The transfer rate was a blistering 571 megabits per second, far too fast for automated security flags to catch in time. Forensic analysts later pieced together a chilling timeline. The attackers gained initial access at 3:14 a.m. Eastern, escalated their privileges to the highest level by 3:19, and began siphoning data at 3:23. In under 7 minutes, 24 gigabytes of compressed files, including internal chat logs, draft reports, and sensitive telemetry from the 3I Atlas intercept mission, were gone. By 3:30 a.m., the connection vanished, leaving behind nothing but a silent gap in the audit trail. Cybersecurity expert Mikko Hipponen has stated that such an attack would require nation-state-level resources, suggesting Event Horizon is far more sophisticated than a typical hacktivist group. The manifesto and distribution. A successful hack is one thing, but what you do next is everything. Hours after the breach, a manifesto from Event Horizon appeared on encrypted forums accessible only through the Tor network. They claimed full responsibility, framing the attack not as an act of digital vandalism, but as a necessary response to what they termed unlawful, cosmic secrecy. Their message was a direct challenge to the global intelligence status quo, echoing the methods of groups like WikiLeaks but with a far more specific target. They warned that the leaked files contained material so sensitive that even senior directors at NASA were allegedly kept out of the loop. Their language was blunt: the world deserves to know what its own scientists have found. But Event Horizon didn't just dump the data online. Instead, they began a calculated campaign, distributing blurred screenshots and heavily redacted memos to select journalists and online channels known for covering classified science. No one received the full archive. It was a strategic drip feed, designed to build pressure and credibility, giving the world just enough of a glimpse to understand the immense gravity of what had been taken. Their final warning was a gauntlet thrown down. The files contain evidence that will force the public to confront a new reality. Authenticating the documents. In the world of leaks, authenticity is paramount, so are these files real? The evidence presented by Event Horizon is compellingly layered. The leaked screenshots are plastered with authentic details: bold, block-lettered confidential stamps, thick redaction blocks, and metadata tags showing UTC timestamps that perfectly match the breach window from NASA's own security audit. We see mission patch artwork in the corners, a stylized comet labeled 3I Atlas Int. Every document carries unique identifiers, routing codes, and internal chat handles you'd expect to see inside a major agency. Technical diagrams and draft tables use Courier font headers and bear NASA's internal digital watermark. We even see screenshots of the classic blue and white NASA email interface, with subject lines like Atlas Intercept, Immediate Action Required, and Telemetry Review, Anomaly Detected. One partially blurred memo lists technical trajectory data, while another redacted report is marked with the access level TSSCI, denoting top secret, sensitive, compartmented information, a classification that restricts access to a small, specific group of cleared individuals. The documents bear digital signature strings ending in JPL for the Jet Propulsion Laboratory, and GSFC for the Goddard Space Flight Center, indicating a multi-center collaboration. Discovery of 3I Atlas. Before the leak, there was the discovery. On July 1, 2025, the real-life Atlas survey in Hawaii, a NASA-funded planetary defense system officially known as the Asteroid Terrestrial Impact Last Alert System, logged a new object tearing through the solar system at an astonishing 130,000 miles per hour, or about 58 kilometers per second. Astronomers immediately flagged it. This was the third interstellar object ever detected, following the bizarre one I/Oumuamua in 2017 and the more conventional two I/Borisov in 2019. But 3I Atlas was different. Early estimates put its size at a staggering 26 kilometers across, roughly the size of the asteroid Vesta, and over 25 times longer than Oumuamua. Its trajectory, calculated by the Minor Planet Center, confirmed it was an interstellar visitor on a one-way ticket through our system, with an orbital eccentricity greater than 6.0. Its path was hyperbolic, meaning it wasn't captured by our sun's gravity and would not be coming back. According to Dr. Larry Deneau, the principal investigator for the Atlas project, An object of this size and velocity is a once-in-a-century detection event. This wasn't just another icy rock, it was an unprecedented anomaly from deep space. Impossible physics and trajectory. Here's where the story takes a sharp turn from unusual to unbelievable. Like its predecessor Oumuamua, 3I Atlas was not behaving according to the laws of physics. The leaked mission logs from July 18, 2025, show a sudden, inexplicable sideways acceleration resulting in a velocity change or delta V of 1.5 meters per second. The object changed course in a way that defied gravitational models. For a normal comet, such a deviation could be explained by outgassing, measured by the non-gravitational acceleration parameter A2. However, just like with Oumuamua, initial observations of 3I Atlas showed no cometary tail, no dust, and no gas coma to account for the push. Its A2 parameter was effectively zero, yet it was still maneuvering. Trajectory analysts were stumped. They ran models accounting for solar radiation pressure, gravitational pulls from planets, and every known natural force. Nothing matched the telemetry. Dr. Amy Mainzer, a leading expert on asteroids, has noted that explaining such a deviation without observable outgassing requires, quote, exotic physics or an artificial origin. The numbers kept pointing to a single, unsettling conclusion. Some force other than gravity was steering this massive object through our solar system. Surface anomalies, the armor problem. When the first high-resolution images from the Intercept mission were allegedly taken, the mystery of 3I Atlas deepened. The object's surface looked nothing like any known comet or asteroid. Analysts flagged a disturbing pattern. Bands of smooth, almost metallic-looking plating, broken by lines that ran too straight and were too evenly spaced to be natural fractures. These weren't the chaotic, jagged fissures seen on Comet 67P by the Rosetta mission. They were seams, crisscrossing the surface in a deliberate grid. One analyst, in a leaked internal chat, dubbed it the radiator problem, referring to a network of raised ridges spaced like the cooling fins on a spacecraft. These ribs cast long, uniform shadows, and their regularity was so pronounced that pattern recognition software reportedly flagged them as artificial. The object's albedo, or reflectivity, was measured at 0.7, closer to polished metal than the asphalt dark surface of most comets, which have an albedo below 0.05. Planetary geologist Dr. Carolyn Porco has emphasized that nature does not produce such perfect, large-scale geometric patterns. This wasn't just an odd rock, the leaked images suggested it might be wearing armor. Thermal signatures and heat pulses. If the surface looked engineered, the thermal data was even more alarming. According to the leaked files, infrared arrays recorded heat vents pulsing with incredible regularity. The logs show heat pooling along the strange, ribbed seams and then bursting outward in tight, directed jets. This wasn't the broad, chaotic outgassing you see in a typical comet. These were discrete, timed pulses occurring precisely every 90 seconds, raising local surface temperatures by over 200 degrees Kelvin in an instant. The mission logs classified this as a directive motion event, a term typically reserved for spacecraft thrusters, not natural phenomena. Even more damning, trajectory analysts correlated these thermal pulses directly with the object's mysterious course corrections. After each 90-second heat burst, the Intercept team logged a subtle but precise shift in its path. The efficiency of this propulsion, measured as specific impulse, was calculated to be far beyond any chemical rocket, consistent with advanced ion or plasma thrusters. Gravity couldn't explain it, solar radiation is constant, and natural outgassing is random. The evidence was building. 3I Atlas wasn't just moving strangely, it appeared to be actively propelling itself. Chemical composition mysteries. The story gets even stranger when you look at the chemical makeup. According to a leaked memo from the Goddard Space Flight Center, the first full infrared spectrum analysis of 3I Atlas yielded a bizarre result. The spectra lit up with incredibly sharp lines of nickel. Now, nickel itself isn't entirely unusual in space rocks. It's often found in iron-nickel alloys. But here's the kicker. In the data for 3I Atlas, the signature for iron was almost completely absent. In the entire catalog of known asteroids and comets, a composition of refined nickel without its constant companion, iron, is unheard of. Furthermore, the memo noted the absence of common silicates and carbonaceous compounds. Meteoritics expert Dr. Meenakshi Wadhwa has confirmed that such a separation of nickel from iron requires industrial-scale processing at very high temperatures, a process not known to occur in nature. It suggests a material that has been engineered, not one that formed naturally. The memo was allegedly sealed within hours under a restricted access embargo, but the data was clear: an object with an artificial structure was made of an equally artificial material. Radio echoes and communication patterns. Beyond its motion and materials, the most chilling evidence in the leaked files points toward active technology. According to the logs, radio astronomers reviewing raw data from the Intercept mission flagged a pattern of faint, repeating echoes in the X-band frequency range. These weren't natural radio bursts or cosmic static, they were precise, clipped signals with a high signal-to-noise ratio, bouncing back from 3I Atlas at regular intervals. What made this truly shocking was the timing. The interval of the radio echoes mapped almost perfectly to the 90-second rhythm of the object's thermal pulses. It was as if something was pinging the object, and the heat pulses were the response. In one of the leaked chat logs, a veteran telemetry specialist reportedly wrote, "It's like someone is pinging the probe and it's answering. The pattern is too tight for random noise." This completely changed the nature of the investigation. SETI pioneer Dr. Jill Tarter has long argued that a truly intelligent signal would likely be efficient and information-dense, characteristics that align with these alleged repeating echoes. The data suggested it could be an active, responsive probe. Expert analysis and propulsion theory. This is where a very real and very famous scientist enters the picture, Harvard astrophysicist Avi Loeb. While he has not commented on this alleged leak, his previous analysis of Oumuamua via the Galileo project provides a stunning framework. The leaked analysis of 3I Atlas goes even further than Loeb's theories. The directed heat pulses and course corrections are consistent with a sophisticated ion drive or a similar propulsion system. But the alleged smoking gun came from a microscopic fragment recovered by the interceptor's dust collector. Under an electron microscope, technicians reportedly saw a lattice of silicon with doped traces of phosphorus, arranged in layers spaced at micron intervals, identical to the architecture of a semiconductor wafer, with visible p-n junctions. A materials scientist would immediately recognize this structure. No known natural process from supernova shock waves to planetary formation can create such ordered, layered microstructures. The memo's summary line, though partially redacted, was legible. Semiconductor structure detected. Artificial origin cannot be excluded. This single finding, if true, moves the conversation from anomaly to artifact. So, what do we make of all this? A 26-kilometer object from another star system moving at impossible speeds, making its own course corrections. It has a surface that looks like armor, a composition of refined nickel, and it pulses with heat and radio echoes on a perfect 90-second clock. And finally, there's a fragment of what appears to be a microchip. The leaked files, if authentic, present a disturbing and profound reality. The questions are staggering. What is this object's purpose? Where did it come from? And perhaps most importantly, what else has NASA found that we don't know about? Don't forget to like, subscribe, and hit the bell icon for more deep dives into the secrets of science and technology. Thanks for watching Sci and Why. After 46 years of traveling through space, Voyager 1 finally sent back data from beyond our solar system that nobody saw coming. This isn't just another space mission update, it's a complete game changer for everything we thought we knew about the universe. The tiny spacecraft has crossed into interstellar space and discovered an environment so strange and structured that scientists are, honestly, rewriting their textbooks. Get ready to have your mind blown by what's really lurking in the darkness between stars, because the truth is absolutely incredible. The Great Silence and Revival. Space exploration hit a terrifying moment in late 2023 when humanity's most distant messenger went completely silent. Voyager 1, our faithful explorer that had been sending data for nearly 5 decades, suddenly started transmitting nothing but garbled, meaningless signals. Engineers at NASA faced an unprecedented challenge, performing brain surgery on a spacecraft using 1970s technology from 15 billion miles away. The culprit was a corrupted memory chip, likely destroyed by the same cosmic rays Voyager was studying. The fix required rerouting decades-old code into backup systems while dealing with a 22-hour communication delay. By April 2024, the impossible happened. Voyager came back to life, and what it began transmitting would change our understanding of space forever. The magnetic revelation. Something extraordinary happened when Voyager's magnetometer came back online. It revealed that space between stars operates by completely different rules. The spacecraft detected an interstellar magnetic field that's dramatically misaligned with our sun's magnetic influence, suggesting Voyager has encountered a galactic-scale boundary zone. These aren't minor variations. They're fundamental structural differences that point to magnetic turbulence zones where galactic fields twist and reconnect in ways scientists never predicted. The readings indicate Voyager might be navigating through invisible cosmic highways where magnetic forces create pathways and barriers throughout our galaxy. This discovery means the Milky Way has an underlying magnetic skeleton that influences everything from star formation to the flow of cosmic material, and we're only now getting our first direct measurements of this hidden architecture. The cosmic storm. The moment Voyager 1 crossed the heliopause in 2012, it encountered a radiation environment so intense it would be lethal to any human traveler. High-energy cosmic rays, accelerated to nearly light speed by distant supernovae and black holes, bombard the spacecraft at rates dramatically higher than anything measured inside our solar system. The jump wasn't gradual, it was like stepping through an invisible force field into a cosmic shooting gallery. These measurements reveal that our sun's protective bubble shields Earth far more effectively than anyone realized, creating a cosmic oasis in what's essentially a galaxy-wide radiation storm. The pattern of these particles isn't random either. Voyager has detected systematic variations suggesting natural radiation corridors that could represent the aftermath of ancient stellar explosions that shaped our galactic neighborhood millions of years ago. The Whispering Void. Forget everything you've heard about the silence of space. Voyager 1 has discovered that interstellar space is actually humming with constant activity. The spacecraft's plasma wave instrument detects persistent low-frequency oscillations that create a cosmic soundtrack most people will never hear. These aren't just random noise. They're organized pressure waves moving through space like invisible weather fronts. Multiple density spikes indicate Voyager is encountering shock fronts left behind by ancient supernovae that exploded thousands of years ago, with their energy still rippling through the cosmic medium. The most fascinating discovery is how layered this environment appears to be. Some regions are hotter, others denser, creating distinct climate zones in what we assumed was uniform emptiness. This cosmic weather system suggests interstellar space has its own complex meteorology. Mapping the invisible galaxy. Every data packet Voyager 1 transmits is helping scientists construct something unprecedented, a three-dimensional navigation map of interstellar space. The spacecraft has become humanity's anchor point for understanding the Milky Way's invisible infrastructure, measuring cosmic ray gradients, particle densities, and magnetic field orientations that reveal the hidden structure of our galactic neighborhood. This isn't theoretical modeling anymore. It's real-world cartography of the cosmos, like having a weather satellite for space between stars. The radiation mapping has profound implications for future human space exploration, as the intensity of interstellar radiation is far more dangerous than what astronauts encounter in Earth orbit. Understanding where natural shields and danger zones exist could determine whether humans can ever safely venture beyond our solar system, making Voyager's measurements crucial for planning humanity's next giant leap into deep space. The Cloudlet Highway. Since entering interstellar space, Voyager 1 has passed through at least two distinct interstellar cloudlets, regions where plasma, dust, and gas density suddenly changes by factors of 2 to 3 times. These discoveries reveal that the space between stars resembles an ocean with currents, eddies, and weather patterns, rather than the uniform void astronomers once imagined. The probe's instruments show evidence of structured plasma ripples with clear boundaries and characteristics, suggesting large-scale organization in what scientists thought was chaos. NASA researchers now believe our sun is moving through the local interstellar cloud, with Voyager helping define its outer edges inside the much larger local bubble, an enormous cavity created by ancient supernovae explosions. These density shifts could affect Earth's exposure to cosmic radiation over millennia, as our solar system drifts through different interstellar environments, potentially influencing everything from cloud formation to biological mutation rates. The Galactic Boundary Zone. So the transition from our solar system to interstellar space turned out to be well, far messier and more complex than anyone predicted. Voyager 1 revealed that crossing the heliopause isn't like passing through a clean boundary, it's more like navigating a chaotic swirl of plasma, radiation, and magnetic forces that shift and change as our sun moves through the galaxy at 450,000 miles per hour. The boundaries Voyager crosses aren't fixed structures but dynamic zones that evolve constantly. Magnetic fields don't align as expected, radiation environments change dramatically over short distances, and plasma waves suggest ongoing activity that scientists are only beginning to understand. This complex interstellar weather creates an environment where the edge of our solar system becomes less of an edge and more of a turbulent frontier zone, where solar and galactic influences battle for dominance in an invisible cosmic wrestling match. The ancient supernova trail. The systematic patterns Voyager 1 detects in cosmic ray intensity and plasma density aren't just random fluctuations, they're actually geological records of our galaxy's violent past, written into the very fabric of space itself. The spacecraft appears to be following trails left behind by supernova explosions that happened millions of years ago, with their shockwaves still carving out pathways through the interstellar medium. These cosmic highways, you could say, channel high-energy particles along preferred routes, and that's what creates the radiation gradients and magnetic field orientations Voyager measures. Some astrophysicists even believe these ancient stellar explosion patterns might influence where new stars form in our part of the galaxy, with magnetic field orientations potentially guiding cosmic material into denser regions that could trigger future star birth. So, the data suggests Voyager isn't just sampling local conditions, it's really giving us a glimpse into the aftermath of cataclysmic events that shape the structure of our entire galactic neighborhood over, well, cosmic timescales. The Eternal Ambassador. While Voyager 1's scientific mission might end within a few years as its power source slowly fades, the spacecraft's journey through eternity is actually just beginning. This small probe will keep silently coasting through the cosmos long after human civilization has either evolved beyond recognition or, disappeared entirely. In about 40,000 years, Voyager will make its closest approach to Gliese 445, a red dwarf star, passing within about 1.6 light-years. It's kind of like a celestial handshake across the vastness of space. The golden record attached to Voyager carries sounds, music, greetings in 55 languages, and 116 images from Earth, all engineered to survive over 1 billion years in the harsh environment of space. This makes Voyager not just a scientific instrument, but possibly the most enduring monument humanity will ever create, carrying the essence of our species into the cosmic deep, long after Earth's continents have shifted beyond recognition. The real discovery. The most profound revelation from Voyager 1's journey isn't about discovering aliens or wormholes. It's really about understanding that interstellar space is a dynamic, structured environment all its own, with weather patterns, magnetic topography, and radiation zones. The spacecraft revealed that our solar system exists within a kind of protected oasis, with the sun's heliosphere shielding us from an environment that's way more intense and radiation-filled than anyone realized. The transition to interstellar space isn't simple, it's messy and complex, with magnetic fields that don't line up the way we expected, and plasma waves that show constant activity. The interstellar medium has layers, fronts, and boundaries that shape the invisible architecture of our galaxy. Most importantly, Voyager showed us that we live in a cosmic shelter. Our solar system isn't just our home, it's really our sanctuary in a galactic storm raging beyond our protective bubble, making Earth even more precious than we ever imagined. So there you have it. Voyager 1 didn't just reach the other side, it discovered that the other side is nothing like we expected. Which part surprised you the most about interstellar space? Let me know in the comments below. If you enjoyed learning about humanity's greatest space exploration achievement, make sure to like this video, share it with someone who loves real science as much as you do, and don't forget to subscribe to Sci and Y for more mind-blowing discoveries about our incredible universe. Until next time, keep questioning and keep exploring.